Hello students, we are starting wave optics 10th chapter today, and here is the first assignment. There are 5 questions in this assignment. Very first is define wavefront, mention types of wavefront. Second one, state and explain Huygens principle. Third one, explain the phenomena of reflection with the help of the concept of wavefront. Next one, explain the phenomena of refraction with the help of concept of wavefront. And lastly, explain Doppler's effect considering the concept of wavefront. So mainly in this assignment we have wavefront, a very new concept given by scientist Huygens in later half of 17th century. Huygens gave concept of wavefront. Up to that time, ray optics was very much in existence, but there were certain theories which could not be explained, certain phenomena could not be explained by ray optics, like interference or polarization or diffraction. So, Huygens was a person who came up with some new idea, a new concept in physics, which is known as wavefront. And with the concept of wavefront, Huygens could successfully explain the phenomena of reflection, refraction, Doppler effect, and later, based on Huygens principle, Thomas Young uh, in 19th century could explain interference, and even Fresnel uh, could explain diffraction. And then later Malu was also a scientist who could explain polarization. So that is overall idea about the chapter. We'll be dealing with wavefront, types of wavefront, and Huygens principle in this video. In the next video, we'll see reflection and refraction of light and maybe Doppler's effect also. So let us start with the concept of wavefront, and then we'll see Huygens principle. Consider a sinusoidal wave. So if I plot the wave, there are different ways of representing wave. Suppose if we plot it like this, now what do we have on horizontal axis? What do we have on vertical axis? So vertical axis may be carrying information like voltage or electric field intensity or light intensity. What we have for now, let me take to be displacement y. Now here, if you are taking time, then you can always express time in terms of time period. So this is the time when one wave gets over, that is t. This is the time when half wave is completed, so it is t by 2. Similarly, this is t by 4, this is 3t by 4, okay, and so on. So you can say this is 1t by 4, 2t by 4, 3t by 4, 4t by 4, 5t by 4, 6t by 4, right? So in terms of t by 4, we can express wave occurrence. Now what if I take phase? Then also I can plot the same graph with say theta here. Theta is symbol of phase. So if I consider the same wave again, and then if I try to express it as a function of say phase, then which values I'll have on horizontal axis? I consider vertical axis to be y again. Now in terms of phase, one wave means 2 pi. We are going to need this information in the coming part of chapter. So when your t time period phase is 2 pi, when you have one wave distance, that is lambda distance, phase is 2 pi. So keep these numbers in mind. Lambda distance is 2 pi, phase is t time period. Okay, so if I want some time, I would say that at capital T time distance is lambda, small t time how much is the distance. If I want phase, I would say that 2 pi phase distance is lambda, at say theta phase, how much is the distance. Similarly, you can relate theta and t also, that when you have 2 pi phase, time period is t. Then if I have theta, what is the time, at what time phase will be theta. So if you have these three quantities clear, it will be much easier to understand the coming topics. Uh, Going back to the figure, if this is 2 pi, this would be pi. When the wave reaches its peak first time, the phase is pi by 2. So in that sense, you can say that this is 2 pi by 2. This is 3 pi by 2. This can be regarded as 4 pi by 2, 5 pi by 2, 6 pi by 2. Now try to relate 6 pi by 2 with 6 pi by 4, 5 pi by 2 with 5 t by 4. So that is how wave propagates. That is how time changes. That is how phase changes. Now suppose if I consider a point source and if I consider different waves coming out of the source. So let me consider say a candle, and there are waves coming out from the candle, say like this. For now I am considering only three waves. Now look at this point. This is first crest, first crest, first crest. So I can say that these 3 points are points having same phase. So if I join this, I get circular shape. Actually in 3 dimension, if you see, you have one wave coming towards you, one wave going inside the plane, and then this shape is not circular, it is spherical. Okay. Similarly, if you join these points are points having same phase, and they assume circular phase. If you can imagine a surface passing through such points. Consider one more situation. See, there is a wave going like this. Let us consider one more, and last one. Now, what if I join these points? See, this is first crest. So, when I join these points, I get a surface which is passing through points having same phase. Such surface is called wavefront. See, this is wavefront which is passing through all the particles having phase say pi by 2. You can not necessary that you choose first crest, you can choose second crest also. Then you have one more surface. So this is also a wavefront. Okay, here also I have joined points having same phase. So such surface is called wavefront. Formally, if you have to define wavefront, you can say that uh, wavefront is an imaginary surface passing through points having same phase. What are the types of wavefront? So if I consider point source, then as we saw that different waves are going in different direction, and in that case if you join the particles oscillating in same phase, bear with my drawing. For point source the shape would be circular, but if you assume that the source is cylindrical like our tube light, in that case some waves are going here, some waves are going here, some waves are coming towards us, some waves are going behind, and then if you join the surface, you will see that the surface passing through particles having same phase is circular one, sorry, cylindrical one. So circular wavefront is possible, not circular, I am sorry, spherical. Spherical wavefront is possible, cylindrical wavefront is possible. Then for point source, if you go at very large distance from the source, then you will see that very small part of such surface is almost plane. So when the waves are parallel, the wavefront is considered as plane wavefront. So there are three types of wavefronts: spherical, cylindrical, and sorry, plane wavefront. When do we get spherical wavefront? When the source is point source. Cylindrical wavefront when you have linear source, or plane wavefront when you choose very small part of spherical or cylindrical wavefront. So that is all about types of wavefront. Now let us go to Huygens principle. Huygens in 17th century came up with very new idea. He said that when you consider a wavefront, suppose I have some source at say point S, and then I have one wavefront. What do you mean by wavefront? I am not drawing waves now. Consider that there is a wavefront xy which is passing through points A, B, and C. Huygens said that all the points on primary wavefront behave as if they are source for secondary waves. What does it mean? That if I consider that from S waves are going out, okay, and then if I choose 3 points, say namely A, B, C, on this primary waves, then A, B, C are also emitting waves. I understand that you find it strange, but that is what Huygens proposed. He said that all the points, here we have considered only 3 points, but according to Huygens, any point on this wavefront would behave as if it is source. So suppose if A is source, A will start emitting waves. So suppose waves of A are going like this. So after some time, I can always assume a wavefront of A itself. So these are called secondary waves, and this is wavelet, you may say. Similarly, I can have secondary wavelet for B also. Similarly, I can have a secondary wavelet for C also. And then if I join these points, say if I join tangents at say A prime, B prime, and C prime. If I join these tangents, I get one more surface which is secondary wavefront of S. Let me call it Y prime, X prime. And you can always choose points here also, say A double prime, let this be B double prime, let this be C double prime. So if you join A double prime, B double prime, and C double prime, you will get one more secondary surface, which may be Y double prime, X double prime. So what was basically Huygens' concept? His idea was that all the points on primary wavefront behave as if they are source for secondary waves, and if you choose that at time t equal to 0, all the points should emit secondary waves, then after some time, say after 1 second, these waves must have some distance traveled, like as shown here. What is this blue circle? Blue circle is the limit up to which secondary waves of A have traveled in 1 second. So now if I draw tangent at this secondary wavelets, I get secondary surface. Now the question here is, if B is emitting secondary waves, we know that at B prime we will get intensity, but we have never observed light coming from B to B prime, because basically S is the source and light goes from S to B. Light propagates in the direction from S to B. It won't go from B to S. So how do we solve this? So I can say that consider intensity of light to be proportional to cos square theta. So when you consider SB and S, sorry, and BB prime, what is the angle between the two? Theta is 0, so cos theta is 1, and hence intensity is maximum. But if I consider direction of wave propagation from original source, and then if I consider BB double prime, what is theta? Theta is 180 degree. I think I made mistake. It's cos square theta by 2. And then cos theta by 2 is cos of 90 degree. And what is cos of 90 degree? 0. And hence intensity is 0. So this is how we can explain that light moves in forward direction only. It will not go back. So if you retrace the path, intensity will be 0. So in short, what is Huygens principle? That all the points on primary wavefront behave as if they are source for secondary waves, and after some small time, delta t, if you join tangents to the secondary wavelets, we have joined tangents, these are the tangents to secondary wavelets, we can generate secondary wavefront. So with this concept, Huygens could explain the phenomena of reflection and refraction, which we'll see in next video. Thank you.